Hello, Assalamu alaikum everyone. This is Zainab from Dice Analytics. I would like to welcome you all for today's webinar on data engineering on AWS. I'm really excited to announce that we have three guest speakers and domain experts with us today. We have Mr. Bilal Maqsood, Senior Consultant Data and AI from Systems Limited. Mr. Bilal is an experienced data engineer with a demonstrated history of working in operations, deployment, and integration of data analytics ecosystem. Then we are very glad to have Mr. Moeed Tariq, who is a big data solution architect at Stars Play Dubai. Mr. Moeed Tariq has 8+ years of diverse experience in telecom, IT consultancy, and video streaming companies. His expertise include big data, business intelligence, data analytics, modeling, visualization, and much more. We also have Mr. Mohammad Munib, who's a lead data engineer at a pharmaceutical company with 4+ years of experience in development and engineering of data catalog, data governance, managing the application lifecycle and its expansion for business units. Thank you so much for joining us today. In today's sessions, our domain experts will be enlightening you about how cloud came into being, cloud computing and deployment models, its challenges and advantages. They will be guiding you about what is actually AWS with a hands-on exercise. In today's session, the webinar will be followed by a Q&A session at the end. So I would like to request all of you to note down your queries during the session. I hope we all get the most out of today's session. That's all from my side. Over to Mr. Bilal.
Thank you so much, Zainab. Just to reiterate, welcome everyone on behalf of Dice Analytics. I welcome you all. I'm Bilal Maqsood. Just to confirm, if you guys can see my screen and hear my voice. Zainab,
Yes,
is that all right?
Yes.
Okay. Okay, great. So should we, all the participants are joining, or should we like wait for like a few minutes, 2-3 minutes?
I think we have 46 attendees right now, so we should start.
Okay, great. If you can please allow everyone to open their mics if they are not currently able to open their mics, so we can have an interactive session. Is
Yeah,
that
let
fine?
me do that. I'm doing that.
Okay, thank you. Okay, guys, I think let's start. I have two guests with me, Munib and Moeed. We have worked in the past. We do currently work on different projects in freelance capacity together, and they will be assisting me today in this webinar by sharing their experience, their data engineering journey, and things like that. Okay. I do have a outline prepared. It's a rough outline. It really depends on how interactive the session will be. I'm expecting a lot of questions and comments from you guys. So the rough flow would be something like we will discuss what is data engineering in general, maybe talk a little bit about what kind of tools the data engineers use, what kind of challenges that we have, what is AWS generally, and how AWS is able to help us with those challenges, and how we can implement these data engineering workflows on AWS, and maybe talk a bit about a data engineer's roadmap at the end of this session. So it looks quite brief, but it really depends on the interactive questions that you guys might have. So let's start with the little bit of ice breaking session. I can already see there are a few people who are raising hands. By the way, you guys can open your mic anytime and ask questions. You can raise your hands for asking any questions. There is a Q&A panel in which you can post your questions, or you can just simply provide them. It's all fine by us. Okay, so I can see There was this guy Ehsan. He was raising his hand. I'm not sure. He has Muhammad Ehsan Chatta. Ehsan, do you have a question or whatever? If you want to introduce yourself or anything. Ehsan, Muhammad Ehsan Chatta. Okay. So anybody who wants to open their mic voluntarily and wants
Assalamualaikum.
to introduce. Okay,
Assalamualaikum
we have Ehsan here.
सर
Assalam.
मोहम्मद एहसान जट्टा सर मेरा नाम है सर मैं AWS ये वर्ड ब्रीफिंग किसका है यानी एब्रिविएशन किसका है यानी AWS ये मुझे समझ नहीं आई अभी तक
ठीक 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 ठीक
ये
we
बता
will
दें
discuss that. हम इसके ऊपर बात करेंगे, definitely बात करेंगे इसके ऊपर. एहसान, if you want to tell us a little bit about your background, आप क्या कर रहे हैं, motivation क्या है आपकी webinar attend करने की, just a little bit.
सर मैं कॉलेज में प्रोफेसर हूँ और एमफिल केमिस्ट्री मैंने किया हुआ है कंप्यूटर के बारे में काफ़ी जानता हूँ लेकिन इतना ज़्यादा नहीं इंजीनियरिंग वगैरह नहीं जानता हार्डवेयर के बारे में इलम नहीं सॉफ्टवेयर थोड़ा बहुत जो बेसिक स्किल्स होती हैं वो
That's very nice that we have someone from academic experience. Okay, Awas Amin is next. Awas, you can open your mic and introduce yourself.
Yes, I'm Muhammad Awasmin, and I have done my MS in computer science from Pyaas.
Awas, आप mute पे चले गए हैं. You are on mute.
Okay, sorry. My name is Muhammad Awasmin, and I have done MS in computer sciences from Pyaas. And currently, I'm working as a data analyst in KIST. It's a buy no pay later fintech solution. And
Very nice,
basically,
very
I
nice.
want to ask, we are going to learn AWS QuickSight, or we are going to learn AWS data tools like Data Brew and AWS Spice, AWS other tools. What we are going to learn today?
Okay. So we will get back to outline after this quick session of introductions, and you will see that what we are going to do today. Okay, so it clearly so by introducing introduction of these two guys, we can see that there is one who has a little bit experience of AWS, who knows what AWS is, and Ihsan, he has some questions about AWS. So we might have to mellow down our discussion a bit. So we might have to go into some of the abbreviations, some of the basic concepts, fundamentals of cloud and AWS in general to get things going. Okay, we have now Temur Bilal next. Temur, please open your mic and introduce yourself. Okay, I think Temur is not available. Tayyab Jalil. Tayyab, you can open your mic and introduce yourself.
Assalamu alaikum, sir. Hello.
Walaikum assalam.
Okay. Sir, myself Muhammad Etl Jalil, and currently I am doing masters in data sciences from Fast Newsies, and I have a background in computer sciences. I have completed my bachelor's in computer sciences, and for the short time I worked in the field of data engineering. So I have a very basic question regarding this data engineering.
Okay,
Sir,
that's great. Please.
सर जो हमारे पास डेटा वेयर हाउसिंग होती है, हमें पता है जो ओलैप हम करते हैं, तो अब एज अ कंपनी ये पूरा सोल्यूशन एक कंपनी को बहुत एक्सपेंसिव पड़ता है, उस ETL की पाइपलाइन डिज़ाइन करना और उसके लिए डेटा वेयर हाउसिंग करना. ये सारा काम हमारा जो एक OLTP पे जो डेटाबेस होता है, सारा काम हम अगर उसी में कर लें, तो what is the best answer के why do we need a data engineering?
That's a very good question, Tayyab. And I would like to go back to my guests to think on this, Munib and Mueed, and they will have some interesting views on that. But first, let
Okay, sir.
me read some introductions from the chat, and we'll go back to the slides.
Oh, okay,
Okay,
sir.
from the
Thank you.
chat we have okay. Khidr is asking, do you provide certificate of attendance for this webinar? I'm not sure. I don't think there is any certificate of attendance on this one. I'm
These
attending students
certificates
from
will
my
not be
office.
provided. Yeah.
Okay, thanks for clarifying that, Zainab. I am attending this session from office. Mic is not working. My question is, are there tools regarding AWS? Yes, definitely we will see a few of them in today's session as well, inshallah. Uzair Mansoor, electrical engineering, in my 8th semester, done some trainings on CCNA, CCNP, AWS, solution architect associate. That's great that we have some technical experts as well. Abdullah Tariq, CS graduate, data analytics, looking to start working on. Okay. Uh, some are not able to turn on the mic. US based biotech company as data engineer, Talha Zafar, Fazur Rahman from Islamabad, then BSc Informatics. Okay, so overall, the audience looks pretty diverse, right? We have people from academia, we have students, CS students, electrical engineering students, and we have some technical experts who have already done some certifications as well. And so the audience is pretty diverse, so we might have to mellow down our discussion a little bit, so that the people who are very new to the data engineering field, they will know that what it is, right? And at least and then build on that discussion, so our technical experts can also have a good time in this webinar. Okay, so let's move on. I would like to start. So there are two questions that I have pinned. The first one was what we will be doing in this webinar generally, and the second one was from I think I'm forgetting the name. I think it was Talha who asked about the data warehouse, and we have to set up whole this infrastructure kind of thing, OLAP thing. Why cannot we do this
Sir
in
Tayyab Jalil.
OLTP system? Yes, Tayyab, sorry, this was Tayyab. So, so let's first have a look at what we will be covering in this webinar. So we will be covering what is data engineering in general, right? So if someone is not familiar with what kind of work a data engineer is doing, what is it eventually, why it is needed, these kind of questions. Then we'll see what kind of tools the data engineers work with generally, doesn't matter if it is on-prem, doesn't matter if it is on cloud, and what kind of a general skill set the data engineers should have. Then we will build on that, and we will talk a little bit about cloud and AWS specifically. There was one question about AWS, that what was AWS? So it is Amazon Web Services. Amazon is a company, and they have built this public cloud offering, which offers a lot of infrastructure, software as a service, and platform as a service capabilities. So it's a public cloud platform called Amazon Web Services. We will talk about a little bit about data engineering challenges, similar to the question that Tayyab has asked about the infrastructure setup of OLAP versus OLTP. So I'm pinning that question again, and we will go when we will go to the challenges part. We will discuss on it. Then we will see a short, if we can, a short hands-on session on building a small pipeline on AWS, and just looking at what it is like to use an AWS service, right? And then at the end we have data engineering. We will discuss a roadmap, right? So it will cover the aspect that some people are asking, that some people are saying in the chat that they were looking to start in the data engineering ecosystem. So maybe they will find something useful in a data engineer's roadmap. So this is what we will generally do in this session. So let's go ahead and start. Let's not waste more time in ice breaking sessions. But still, mics are open. You can ask a question anytime. So let's start with what is data engineering. And first, I would like to get some insights from my guests, Munib and Mueed, if they can shed some light on what is data engineering in general, right? Maybe a quick 1-2 liners, guys.
Hi everyone. So basically, this is Moit. So, uh, all right. So, what is data engineering? So basically, it's a buzzword you heard every day in your routine work. So, data engineering, from my point of view, data engineering is something like we are getting data from multiple sources. Like we have some operational systems that are actually producing the data. So basically, what we really need to do at the end is to do some analysis on that particular data. So we are actually not doing that analysis on the source systems. For that reason, we are building data engineering pipelines at our end. So we are actually fetching the data from the source systems and then transform that data into appropriate format that we require, applying the business rules, and then basically provide this data to the business or the we can say business analyst or the BI analyst, and they actually develop some reports on it. So basically, fetching or getting the data from the source, transforming it, and then provide it to the end user. This is what I guess, in simple terms, data engineering is from my point of view.
That is, I think, a very uh, great comprehension of a very vast field. And I heard a lot of these pipelines, transformations, optimization kind of words. Munib, what do you have? What do you have on that? Do you have any comments on data
Yeah,
engineering?
hi everyone. So just to add to what Mohit has said, he has pretty much summed up the entire data engineering. So at the end of the day, it's the complete life cycle where you are basically going for ingestion of the data. It could be from a source system, it could be up, and at the end of the day, you're going to build a pipeline on that. Now, a word that pipeline that everyone keeps hearing about is what's it's actually, it's a workflow that where the data is going from and coming to at the end of the day to a source system. So it's at the entire, if I sum it up, the pipeline word, it's just a workflow that the source system is giving the data, and at the end of the day we are putting it in a target. Now the pipeline could be in many different forms, many different way. It could be through a tool, it could be through any kind of script, shell scripting. So it depends from case to case. But and the other word, that integration. So whenever the pipeline is there, you are gonna get the data from one source and put it in another source. So that is pretty much what the integration is. Sometimes it requires just bare minimum, just putting the data in through a copy paste command, and sometimes it requires engineering as well. So these words from time to time mean different thing, but it's in a broader sense, that's what they pretty much mean.
I think very nicely summed up with from both our guests. If someone from the audience, if they want to share some points regarding data engineering, if they have done that, and the floor is open, you can go ahead. But let's segue to this visual representation of data engineering. I really like this infographic. I got it from LinkedIn, and this pretty much sums up what our guests have said and what data engineering is in general, right? So I think it basically starts from here, right? It basically starts from a question, right? So for example, you are a business, and let's start very small, right? So you are a cash and carry service, like Metro, like Alfala, like Imtiaz, right? So you are selling your products, and at the end of the day, you want to see what is your total revenue, right? So you might have a system here who is capturing all the products that have been sold during the day, right? So when you go to the counter, you scan a product, there is a line that goes, okay, this product has been sold. It reduces one quantity from the inventory and places this line, okay, that this is product number P1 and its price is, for example, X rupees, and it goes into this database, right? So it is like this line by line going into this database at the counter, right? But they, at the end of the day, the owner wants to see the total revenue, right? So what you will do, you will do some transformation on this data, right? Well, this is very simple transformation in this case, which is you are summing your data, summing your revenue, which is, for example, X plus Y, all the product prices, and then you are reporting here at the end, right? This is a very, very simple and very, very common example that all of the people from audience can understand that, okay, so in this way, the source data is going into a database. You're using some kind of a mathematical function on that data, and you are providing this result in the form of a report to the business owner, right? Whoever the owner is, that cash and carry, right? And from with over time, you want to see the owner wants to see it like this. So for example, time is on this axis, right? And with the passage of time, your sales or your revenue is on this axis. So he wants to see with the passage of time what his total revenue was, right? So it might be something like this, right? So it is increasing over time. Maybe there are some seasonal peaks and drops in your data as well, right? Sorry about that. So this is where it all starts, right? From a question from your business owner that, okay, I want to see that how my business is performing, right? And it is the job of data engineers to get that data from wherever they want, and from wherever the data is residing at the source, and then present it gracefully to the business owner, right? So for example, if your business owner, he wants to know that how his sales are performing as compared to when these are correlated with weather, right? So he has a suspicion that, okay, when the weather is not good in our area, then the sales are not happening properly, right? So he poses this question, okay, I want to see what is the impact of weather on the sales of my products, right? So maybe the data engineers have to go to some weather API, right? And collect that weather's data from there and correlate it with the data that the customers have produced by buying the products, right? Just giving an example. The overall, again, going back to our guests, do you have like any points about the overall flow of this data engineering pipeline? I really like this infographic, by the way, and I really want you guys to comment on it. Do you think it's an accurate representation of a state-of-the-art data engineering pipeline? What do you think, guys?
Sajid here. I just want to comment one thing. What is the relation between different data sources you have, like legacy systems, SaaS apps, and different applications and web services? How they are connected with the other data sources?
Okay, I think that's a very good and very valid question. I think I will route this to one of our guests, Moeed, if you can, from your experience in the industry, what you can say about the different source systems. I mean, why do we have different source systems? Are these correlated or not? How these are connected? What are your thoughts on that?
All right, can you please repeat the question?
Yes.
So,
So the question
basically
was,
my question is,
Yeah.
okay,
please carry on.
Please go ahead, Sajid.
Okay, so my question was, we are showing different sources. We are getting some data. So what is the relation between different data sources like database and legacy system, how they are connecting and how they are giving data to show the business end? Like,
right. So,
what is the way between connection of database and a legacy system?
all right. So the thing is basically I think I can this is what I get from your question. Basically, you need to know about the relation between different data sources, right?
Yes, I
Yeah,
think this is
yeah,
the question.
yeah, exactly.
Particularly as such, I don't believe there is any particular relation between different data sources. The thing is, we have, I think if we talk about more specifically about this picture that is actually showing on the screen, the thing is that picture actually trying to depict the main reason, like we can have different type of system with us, but it doesn't mean like for any organization, they don't like, it's not compulsory. Like they have databases, they have legacy system, they have SaaS system, they have application, they have web services. It's totally again depend on organization to organization and particularly their use case as well. So most of the time, most of the organization definitely, yeah, they do have databases with them. And those databases, what we really call to them is basically OLTP systems. Yeah, OLTP system are basically the transactional systems. OLTP, that is online transactional processing. So online transactional processing system are supposed to do what they really need to do is basically capture. Basically, they are actually dealing with the operational need of for any organization, right? But when we talk about the analysis part, we really don't do that part on the transactional system because the nature of the system is transactional in nature, and those systems are meant only to capture the transaction successfully. And when we talk about the analysis part, then we have OLAP system with us. OLAP system are designed with different models. They have different techniques to design that system. And the core purpose of OLAP systems are basically to perform analysis on those systems, right? So legacy system, that's actually that is actually in this picture. So legacy system can be basically some old system. We can say some system that we are using from like 10 years ago or maybe older systems, and but we are still receiving some data on those systems. So basically that actually picture showing that we have some databases that are actually generating the transaction data. Then we have some legacy system that there's some sort of data that is still available or still producing on legacy system. Then we have some applications that are running and that are actually producing data as well. So basically what we are doing here is basically the data warehouse is single point of truth for us. So to make data warehouse single point of truth, we need all the data in the single repository. That is our data warehouse. So we have multiple sources. So we can have multiple source system. We can have only one system as well as a source. But in most of the cases, we have different APIs that are actually producing data. We need to sort that data in data warehouse. We have some databases like billing system. So that act as a source. We actually copying the data from those billing system into our data warehouse. So basically data warehouse is a single point of truth, the centralized repository for reporting, and we can have multiple or can have one or multiple source system for producing the data, and that need to be ingested in data warehouse. So that's it from my side.
I think this is I think very comprehensive answer to what Sajid has asked. I just want to add one point here. Just giving you an example of from a telecom system, right? So if we see a telecom system, you have prepaid and postpaid connections, right? Prepaid, in which you are loading a card, and postpaid, in which you are actually paying the bill at the end of the month. From the source point of view, wherever the infrastructure is set up, these are two separate systems, right? So you can say that, okay, this can be a postpaid system and this can be a prepaid system. From source billing point of view, these systems are independent. But at the end of the day, your business wants to see total revenue, right?
Okay.
Total revenue means whatever number of calls you have made, whatever data you have used, whatever messages that you have sent, whatever the total amount of revenue that a company has generated, regardless if it was prepaid or postpaid, they want to see it here, right? So you should this ecosystem will actually combine sales from both of these systems and present it at the end here. Okay, So this can be different, coming from different data sources, and it can be a legacy system because some companies, they might have a post-paid system from I'm not sure, from whenever the inception of telecom systems, right? So this system can be quite old. Its data formats, its interfaces might be quite old, but all this diagram is depicting is data engineers have to create and maintain those integrations from their warehousing systems or analytical systems in general, right? So I hope this sums up this overall workflow, but this does not mean that it is always that complex. Like Munib pointed out in one of the previous questions, that it can be very simple. It can be as simple as this pipeline, right? And in fact, this was one of my first data engineering pipelines that I have built. One of the many of the first, right? So what we were doing, there was a dashboard, right? And we are presenting some kind of data on this dashboard. This dashboard was created in Excel, right? Microsoft Excel. Please pardon my writing. I'm not very used to using this stylus thing. So what we were doing, we were presenting this data in Excel, and we were getting these CSV files, right? And what we were doing, we will copy the data from CSV files and append into a master Excel file, right? And then connect this master Excel file to this Excel file, pivot the data on different dimension and present. So we have to do a lot of manual work at that time, and we had to. So there was like two requirements that we have in mind. One was to do some automation of this workflow, right? Make it run in an automated way or slightly automated way, if not fully automated. And the second one was the data was growing, right? But the Excel, it has 1 million rows per sheet limit, right? You can definitely use multiple sheets, but it is always better that you make only one table or one sheet for your data, right? So what I did at that time, I was pushing those files into a directory, and I connected this directory to a Microsoft Access database, and what it was doing, it was using a macro, which is just some kind of a function or code you can think of, that functionality is available in Microsoft Access. By the way, Microsoft Access comes with Microsoft Office, and it is a standalone database that you can use for small workloads. Okay, so this macro was picking up these CSV files from this and appending it into a Microsoft Access table, right? And then I connected this Microsoft Excel dashboard to this database, main table of this database. So this can be as simple as this, because it comes on the definition of the data engineering in general, right? You're picking up data from some source, you are doing some processing on it, maybe summing it on some dimensions, maybe creating some other dimensions from it, and then presenting it to your management, to your business owners, right? It can be as simple as this. But it's nowadays it's really not that simple. I mean, it can be your one of the many first pipelines, but nowadays with all the big data and the different kind of tools coming in, it can be really complex, like this one. This is an actual data engineering pipeline that we see nowadays, and we work on these kind of complex pipelines, data engineering pipelines that we have. By the way, if someone has any comments on whatever their first data engineering task, or one of the first pipelines that they have built, I would love to hear that. Let me check in the chat if there are any questions. Okay, so can some data sources be connected? Android developer just must be most difficult part, I guess. Yes. Is seen and saved with me. ADF and ADF. Okay, starting from the first one. So I will try to give answers that are related with the presentation, and there will be a dedicated session at the end as well. Okay, I hope that's fine. So someone is asking what is ADF and AWS and if they are same. So these are two very different things. AWS is Amazon Web Services, and it provides a lot of different services. And ADF is actually a ETL part of Microsoft Azure's platform, right? So AWS is a different public cloud. Microsoft Azure is a different public cloud, and ADF is one of the services of Microsoft Azure's public cloud, right? Which is Azure Data Factory. So this is the difference. Ingest is the most difficult part. Yes, we will come to ingestion. Data sources be connected. Yes, data sources can be connected, and eventually this is what is happening in the data at the data warehousing or the analytical layer. You are connecting data from different data sources, right? So for example, here at this point, you are actually connecting your data sources, this into this generic data lake layer. Okay, generic data lake layer. So you are actually connecting your data sources. Okay, please move ahead. Okay, we have to pick up some pace. Okay, let's move on. So this is one of the very complex data engineering pipelines out there. I mean, and all the data engineering pipelines, they have these generic steps, right? You collect your data, right, from different data sources. You ingest your data into a unified platform, right? So normally nowadays what we do, we build a data lake to ingest our raw data that is coming in, because the size of data and the frequency or the velocity of data by which the data is coming in has increased a lot. So we have to build a data lake at this layer, and we will ingest our data into our data lake. This can be on HDFS like here, or it can be on AWS's S3, or it can be on Azure Blob Storage, whatever cloud platform that you are using. Then there is a phase of preparation and computation, right? This is also called transformation phase, right? In which there are some batch jobs that you might be running with Apache Spark or Apache Beam, right? There might be some data science workflows for which you're using TensorFlow, or maybe you are getting some real-time data and you are processing it using Apache Flink, right? So these are different tools specifically made for different type of workloads, right? So this is what you might be doing to transform your data, right? These transformations can be of different types. We're not going into detail of that here, but this is eventually what is happening. And then you are pushing those aggregated data or transformed data into a central repository called a data warehouse, right? And like Mohit said before, that a data warehouse is a central point of truth. And from there, maybe your data scientists are picking some data for their data analysis. Maybe you have built some dashboards for each of the business streams that you have. Maybe you have some notification and these kind of services available, which is generally come under the presentation part, right? On this point, I would like to pause for a moment and go back to our guests for them to comment on another thing, right? So this might be this was like a quite simple workflow. This is a very complex and production level workflow, and it has a lot of these tools which can be overwhelming for people who have joined this webinar and who are saying that okay, they want to start in the field of data analytics. So I would like to go back to our guests, and I would like them to comment on, I mean, what do you guys think the tools or the tools in general that the data engineers should have to get started in data engineering or get going in data engineering? Guess.
Yeah, so let me take this question. The thing is, I did ask these questions by a lot of students as well from time to time that we want to get into the data engineering, but when they see the JD of any kind, they're like, okay, we don't know any of the tools at the end of the day. But here's the thing: if uh, you get freaked out or get afraid by any of those, you're not gonna get started. So if you don't start learning one by one, it becomes a massive hurdle for you to get entered. Now, the thing is, in data engineering, that is very refreshing. That if you have experience with working with something, it could be like, let's just start with, you know how to write SQL queries. Yeah, you are already halfway there. The thing is, a lot of the tools rely on it very heavily. Then comes the next thing. Okay, now I want to get familiarized with something. I want to get specific with something. Now tools come into play that serve different purposes. There are many different open source tools. Talent is a very good example, and it's very frequent and very dominant in the industry as well. So you can start from there. Okay, I'm gonna learn this one. Now the next thing is, okay, I want to learn some workflow tools. Then NiFi comes into play. It's an open source tool. You can start working from there. It's gonna make the job even more easier. So the thing is, uh, if you have experience with any of the tools, not regarding, I'm not going to tell that just Talent or NiFi and everything, you are halfway there with a newer tool. It doesn't, you will see many specific use cases for a specific problem that's very niche, but you don't know the tool for that one, but you have experience with another one that behaves in a very specific manner. So you are halfway there already. Learning a tool is not a big hurdle in data engineering, especially if you are talking about cloud, you are talking about anything else. It's not a big hurdle, but it's just getting started. Once your leg is in the door, it's just you're gonna take some small steps that can get to know the new tool as well. Because you can say the people who are working in an organization and they start implementing the new tool, they don't have an idea, but it just takes some small steps and your previous experience working interacting with an older tool that's gonna familiarize you and get you to the next level. So if
That's
you get
true.
asked if there is a tool that you're not familiar with, don't get afraid that yeah, it's not something. But actually be happy that yes, okay, I'm already familiar with a very specific other tool. Let's see what are the familiarities, and you're gonna find a lot of familiarities in the matter. So
That's, I think, very, very nice and and I think it must be very motivating for some of the listeners that have joined this webinar who are starting out in the field of data engineering. Mohit, do you have anything on this? I mean, data engineering generally. I
So
mean,
someone
what
asked
are
a
the
question.
tools?
Yeah. So basically, someone asked a question like, is data engineering the same as ETL? So I just want to put some light on that point. So
Great
basically,
question, by the way.
yeah. So basically, previously, these actually terms are interchangeable, right? So we have actually idea like if someone asks about a data engineer. So basically, the thing that come in our mind is basically, oh, you guys are the one who is actually for this position should have basic understanding or like understanding of ETL. But now things change over the time, right? So basically, now it's not only about ETL. Like it's not only about you must have understanding of any ETL tool or some framework. Now it's basically combination of multiple things or tools and technologies. If you go through some of the JDs of any company like IBM, Teradata, or any company, so basically you came to know basically that in the JD, you basically if you go through the JD, you can check. They actually mention if there is a data engineering related position, they are looking for someone who has understanding of SQL, right? They must have understanding of any ETL technology or tool, let's say Talent, as mentioned by Muni. Then basically they ask, you must have understanding of any cloud platform. That can be Azure, that can be AWS, that can be Google Cloud. And then DevOps, right? The CI/CD term that is actually very common these days. The CI/CD, continuous integration, continuous deployment term is very common these days. And so basically, and one programming language is must, like Either it's Java, either it's Scala, or it's Python. So basically, any programming language, any ETL tool, SQL, then cloud, then DevOps. So basically, now these are actually the 4 or 5, we can say, the technologies and the components that make a good data engineer these days. So it's not only about the ETL or the SQL. Now it's basically a combination of multiple tools and technology are diverse. A person who has a diverse experience in all of the technology make a good data engineer these days. So that's it from my side.
I think great points by both our guest speakers, which is and these tools and technologies give us a kind of a segue to the toolkit of data engineers nowadays. And let me this slide of containing a lot of these tools might be a little overwhelming for many of our listeners. But let me tell you one thing that even me or any of my guest speakers have not worked on all of these tools, right? So it's not like that you have to know each and everything out there. Whatever you like, for example, like they have said that you can start with SQL, right? So maybe you start with maybe there is a possibility that you start here from the warehousing part, right? You are fulfilling ad hoc requests that are coming in from different users, right? You are maintaining different kind of queries and workflows inside the data warehouse, so you can start here, right? There is a possibility that a data engineer is only working with data warehouse, right? But that does not mean that he or she will not ever work on all of these tools, right? They might be picking up some data from Spark or from HDFS using Spark, right? And if you know SQL, you can use these kind of tools like Spark or Hive, right? These are very common. And there are a lot of other dimensions to data engineering or building data engineering pipelines in general, right? So for example, you build a workflow, right? Like I said before, there are different steps. You have to acquire or get some data, right? You have to ingest it in your analytics platform. You have to compute or transform that data, and then you have to present that data, right? So we have tools or technologies in on all of these fronts, right? So for example, we have for ingestion, we have a lot of these tools, right? Someone in the chat was saying that he has worked with Airbyte or something, right? There are also software as a service tools, so for ingestion, right? So for this, you don't have to buy servers, install patches. Software as a service tools, you can just start coding and they will work easily. You don't have to procure any servers for them, right? Then you will have object storage tools, right? You are getting your data from different sources and you are then placing them into your object storage, right? Mainly these object storage, they build our data lakes, right? Data lakes. Sorry about that. Data lakes. Okay, so very important and very famous is S3. If you're using S3, Azure Blob Storage, Google Core Storage, all of these are public cloud platform. If you're using something on-prem, you can use MinIO or HDFS, something like this, right? And then there are computation engines and analytics engines, right? Normally, computation engines are used to pick up data from object storage and get back to analytics engines or something like this. Or sometimes analytics engines are getting directly ingested from these tools, right? So analytics engines, these are actually your data warehouses, which are single points of truth, right? Snowflake, Firebolt, Redshift, Teradata, these kind of tools, these are very popular data warehousing tools. On top of that, you might have to handle different kind of file formats, right? So maybe your data is the data from source is coming in the form of CSV files and text files, right? But these files are very bulky, right? So you might have to store it in a storage efficient format. So you might be using ORC to store that data in this data lake, something like this, right? And then for automation and workflow scheduling, these kind of things, you might be using some kind of a workflow management tool, right? Like DBT, Airflow, this kind of things, right? Because you don't want to be doing this manually. We always do it in an automated way, right? And so this is what is generally happening. You're using some ingestion tool to ingest in your object storage or data lake. You are, sorry about that, you are pushing that data, or you are doing some transformations on data in your analytics engine. You're using different file formats, you're using different scheduling mechanisms, you're using different tools to monitor and monitor the operations of your data engineering pipeline, right? Your data scientists, they might be using different kind of notebooks like Jupyter, Zeppelin, these kind of things. And there is also a dimension of data quality and data governance that has piqued a lot of interest these days, right, amongst data engineers. And let's pause here for a moment, and I would like to go back to my guests, and if they have any comments on the importance of a governance system or a data quality and observability systems.
Yeah, I want to add on the data governance side, because right now, particularly, I'm working on this very field for data engineering. So one of the questions that we had was while we were building up the data governance model. So a very interesting thing came around, and that was we had data stewards that are going to be responsible for certain data, and we're going to do a data connected silos representation. And an interesting thing that came into is that we were giving names to different data sources automatically. So it building up, and it will be passed on to the source system. Now, when that source system was going to be handed out, someone needs to go in and manually approve that name before it can show up into the system. So that is one of the data governance lifecycle. Now, what ended up happening was we said, yeah, there are so many sources, but you still need to go into the application and approve it. The reason being is it's better to pass on lower data set than to pass on the wrong data set. Now, the issue that was highlighted was some of the applications were using different departments were using the same abbreviation for different construction. So now there were 3 different departments. They were using different abbreviations, but at the end of the day, the abbreviation was the same. So it became a very, very big issue when working in a connected lakehouse. So the data governance part became apparent that you need to ensure that the quality of the data is there rather than data. You can have as much data as you want from open source system, but if there is no quality or there is no backtracking in that data, it's not going to be worth your time to invest in afterwards. You can build models on top of it, but at the end of the day, what results you will get will be garbage because you never looked into the quality of the data set. So there are many different ways to go about it, and some of the tools are already listed, and Sablara has gone through this. So I'm not going to go with a specific tool, but whenever you are working with the data, it's better to highlight the quality rather than to speed. You can generate much data with many different open source tools, but the quality is what's going to get you in the short term and very speedy way.
Well, that's some great addition to the governance part. I would like to segue to this discussion to one other point, right? And Moeed, I would like you to share your point of view on that. Uh, these are a lot of tools, right? And and data engineers generally, like for example myself, we do work with a lot of them on like daily basis, right? What I would like you to shed some light on is, then what's the difference? What do you think? Isn't that then software engineering, right? Because these are all software tools, and then what's the key difference between a software engineer using these tools and data engineer using these tools? If you have some thoughts on that.
Bilal, I guess we have some slide on that as well. That question is more related to like the data roles and skill set we have in the market, right? So basically, that is actually the important thing anyone need to understand. Like people actually get easily confused around what is data engineer, who is actually data warehouse engineer, and like who is the data scientist, and what's the difference between a data engineer and data analyst. So I think that actually slide, yeah. So basically, we can actually have that check that slide. Like these are actually the different roles we have in the market. Like we have data engineers whose core responsibilities are actually building the data pipelines and bringing the data from the different source systems and translating it. Like it's not that much easy job. Basically, we have different type of systems that are actually producing different formats, right? So basically, we have structured data with us. We have data in the form of files, and then we have some semi-structured data as well, and some unstructured data as well. So basically, creating a path for the end user or for the business analyst, that actually the job of data engineers. And here, actually, I mentioned some of the tools and technology that actually data engineers going to use in their day-to-day routine work. And then we have data scientists as well. So data scientists are their role is quite different. So basically, they are actually exploring the data, like they are actually trying to get some value from the data, like they are actually trying to identify basically the patterns from the data, right? So Bilal, I guess if you can please open that slide.
Sorry about that.
Yeah. No, it's okay. So then we have software engineer. If you can look at some of the technology that is actually overlapping between data engineer and software engineer. So software engineers are more specifically towards like application building, then website development sort of stuff. But again, data engineer and software engineer have some common tech tools and technology that they are using in their day-to-day life. Let's say the databases. So either it's data engineer or software engineer, both have to interact with the databases. Then Linux or Unix, some file system, and then some programming language. As I already explained, the data engineer should have understanding of any programming language, you know. So basically, we have data from multiple formats. So basically, transforming that format into an appropriate one or the desired one needs some addition of any programming language other than SQL, right? So basically like Java or Python, basically we are actually using it to parse the data from one format to another format. So basically either Java or Python or Scala or C. So basically in which we actually write the parsers, and those parsers are actually running before any ETL job, and that actually transform the data, transform the data into appropriate format. So basically, then I guess there is one more role that is actually missing in this slide, that is BI engineers. So BI engineers are different from data engineers. Like data engineer bring the data from source system and to them, and then BI engineers actually these guys are mostly their job is related to reporting, right? So basically they are working on the data which data engineer bring for them from different systems. So basically then BI engineer job comes. So basically they start building reports on the data which already is present in the data warehouse. So I guess these are actually the roles, the data engineer, the data scientist, and BI or data analyst. So these are actually the roles that are available in, you can see in every company that is actually working around data. So basically, these are actually the main roles that are available in any organization.
I think very nicely summed up these differences. We can definitely discuss these differences or the roadmaps or the points where to start at the end of this session. But let's move on to the challenges that we generally face. These are not a full list of challenges, but these are the general challenges that we face. And the very first thing with the infrastructure setup and the cost to set up that infrastructure, this is the same question that someone asked. I think Tayyab asked in the beginning, that why don't we do that on an OLTP system? Why we have to set up a separate infrastructure for our analytical system? And I think Moeed did point out some things about the OLTP and OLAP system. But coming back to that point, infrastructure setup and cost is definitely a challenge for any data engineering ecosystem, right? Because we don't do these kind of analytics on our source systems or OLTP systems, right? So there are two separate systems. So for example, you have an application, right? So for example, you have an e-commerce business, right? Your user is coming in. Sorry about that. I'm not very good at using this stylus. I think I should practice more often. Okay. So your user comes in, places checks out an item, puts in the cart, goes to checkout page, and order that item, right? So this ecosystem is your currently running ecosystem on some infrastructure layer, right? Maybe you have 10 million users, right? Which are and you have peak hours around I don't know, maybe around evening or late at night, something like that, and you have 10 million users coming in at the peak hour, right? That means whatever your this system is, for example ordering system or viewing or checkout or cart system is, that will be already overwhelmed with those with the load of those 10 million users coming and browsing through your website, right? So for example, you're showing 10 products per page. Those products are you're getting by querying some database and then showing that web page, right? So it is not advisable to use that same system where having this much amount of load to use for your analytical workloads, right? This is one point. That's why we have to set up a separate infrastructure for our data engineering system. Second point is that the Mueed mentioned earlier is OLTP versus OLAP, right? So your source systems, for example, user is buying a product and that product is getting added into your orders table, right? So that is a OLTP system, right? Transactional system. That system is specially designed for transactional data, right? It has very good insert speeds. So for example, if 10 million customers are buying 10 million products at one time, this system will be very this system is transactional system and will be very good at handling those requests and keeping track of all of them, right? But this system but analytics is getting total revenue or getting how many products how your products performed, which is your most bought product, these kind of questions, right? And like we said before, this is the analysis of history over time, right? Your transactional systems are not designed for these kind of heavy analytical queries. So for that we have separate systems which are called OLAP systems, right? Your data warehouses are comes under the umbrella of OLAP system because they are specialized hardware designed for that analytical queries, right? So this is one other point, that we have to keep those things separate. And even for a small business, so for example you have a cash and carry, you don't have that much amount of workload, it is possible to do it on the same system, right? But for big data analytics, you cannot afford that, right? Where you have multiple sources. So maybe you have an order system, maybe you have a user tracking system, maybe you have a guest user tracking system, these kind of, and maybe you have different kind of microservices wrapped around all of these systems. So you have data coming in from all of these different systems. It is not possible for these databases or OLTP systems to compute all these analytics on their own, right? So we have to build separate. So we have to build separate analytical system to decouple both of these. So if there is a problem with our analytical system, that will not cause any effect on our processing or ordering systems. Our application will be fine. It will be running as it is, and we can take care of analytic system because it has no dependency on that, right? So this is a truth that we have to set up uh, infrastructure separately for our data engineering systems, right? This is exactly why we move data from different source systems into a central repository or analytical system, because we want to compute those analytics on top of that, right? So we have to build infrastructure separately, and it does have a cost, and it does have scalability, availability, and security issues, right? And I would like someone from my guests to shed some light on these aspects, right? So for example, scalability, what do you think, how uh, our data engineering ecosystem that we have built now, currently we are talking about on premises systems, right? So for example, you have a website, you have like your one server, you have bot, you're running a website on top of that, and you have another server on which you are running your data engineering workloads, right? So how this impacts scalability, availability, and security of your systems? Munib, Moeed, if you guys want to share some insights on that.
All right. So if we talk about the scalability for any system, so basically the terms that are actually using the market is basically the vertical scaling and the horizontal scaling of the system. Right now, we are actually in the decade, or we can say talk about more about the big data. So basically, I will talk more about the horizontal scaling aspect. So basically, horizontal scale. Just want to give you a brief overview about the difference between vertical scaling and horizontal scaling. Horizontal scaling is simply if we just keep this example or very simple. So let's say you have a laptop and you want to increase the resources of your laptop due to some requirement, let's say storage or processing. What you really do, you go to the market and ask for a new RAM or a new hard drive or additional hard drive. This is what we call, in simple word, is vertical scaling. Like you are vertically scaling your system. So this is what we usually do when we talk about any organization. So basically, they forecast like what kind of volume or what kind of traffic they will have in the future. So basically, they raise the requirement to the vendors. Let's say IBM or Teradata. What they really do is, so basically they have to get approval from multiple stakeholders or multiple departments, from the management, from the procurement, from the finance, and definitely from the top management as well. And once they are done with the once they are done with the approval part, then the procurement part will get started. So basically, they will raise a request to different companies. So basically, they come up with their bids, and so basically, this is a process that is actually going on during the procurement of any hardware. So once they are done with that part, they actually build their own data center because we are talking about the on-prem solutions. So on-prem solution means basically we are having our own data center physically located in somewhere, like usually in our own offices. So what come next? What if the requirement get changed? Like your application got unexpected number of users. What will happen? So the thing is basically your current existing infrastructure is unable to cater your let's say requirement for data storage and definitely processing. So what you really need to do is basically again start the same process. Initiate the request, calculate your requirement, initiate the request, get approval from the management, and start the procurement process. So basically, this is what company usually do. So basically, now come to the horizontal scaling part as well. So basically, horizontal and vertical scaling, these are the terms. Basically, these are actually what company used to do when they have to increase their resources, right, in terms of storage and processing. But if we talk about the cloud environment, so basically that was actually the challenge which I discussed before. So basically they have to repeat the whole process. It is time-taking process, let's say 2-3 months, 2 months, 3 months, 4 months. So depend on the vendor, right? So basically that was actually the main challenge any company face. Let's say you want to, let's say, we can say, if you want to launch some application, right? So launching an application definitely requires some sort of infrastructure. So basically you have to spend some cost on that, building that infrastructure first. You need those expertise, like you have must have some resources who are actually expert in setting up the infrastructure for you, right? And then basically after some time, you came to know that like the existing infrastructure you set up is not capable enough. to do the storage and processing. So basically you have to repeat the whole process. So in simple word, that was actually a challenge any organization face. So in our next slides, in a couple of next slides, definitely we will look into the solution, how AWS or any cloud service provider basically provide the solution for this challenge. So that's it around scalability. Amudeep, if you want to add anything about availability or security.
I think let's quickly move on to couple of next slides that, and because there are a lot of points that Moeed mentioned that we have covered in the upcoming slides, and I would like to quickly skim through those points so we have less ground to cover again. We will cover the retention use case at the end. But I think Moeed has some valid points around scalability that whenever so we are already investing our time and money in setting up the infrastructure, right? So we are planning ahead. We have to spend a lot of money buying those servers. So for example, we buy 10 servers and we say, okay, these 10 servers will be enough for the next 3 years, right? And we buy those servers, but suddenly there is another source comes in and your business wants to analyze that data as well, right? And your estimate of 3 years for those 10 servers falls down to 1 year, right? And like Mohit said, you have to plan again and buy more servers. So a lot of these challenges related to infrastructure, scalability, availability, and security, they lie around on-prem systems, right? You have to be responsible your physical security of your on-prem systems, right? You have to patch your servers yourselves. You have to take care of the licensing yourselves, right? So these are all the challenges that come with on-prem systems. You're already making your applications, you're already procuring servers for your application. Now you have to create a separate system for data engineering as well and maintain that as well. There is obviously electricity, fuel cost that you have to keep in mind as well, right? So the answer to that we what we can do to avoid these scenarios, we can move these things to cloud, right? And AWS is one of the public clouds that is out there that provides all these features that you can get with your on-prem systems, right? So for example, you are building a website. What you do, you buy a server, you put it online and create your website on that, right? In that journey, you have to go yourself, pick up a server, check if it's everything is all right, and and then after that you will build the code of your website, right? But with AWS or any public cloud, what you can do, you can procure those servers or those machine in the cloud within a matter of minutes and with some clicks, right? So you don't have to manage that infrastructure now. All you need to care about is your code, is your application, right? Is your business, right? So AWS is one of the cloud providers. It provides a lot of these different services around compute, around storage, around networking, different kind of analytical service, and you just don't have to buy the servers now, right? You just can procure them in from the cloud. And there are a lot of other cloud providers there as well, and they have different kind of offerings, right? So for example, AWS, it has two public cloud competitors, very big public cloud competitors like Azure, Google Cloud, but AWS is clearly the market leader. It has around 70% of market share. It has state-of-the-art mechanisms to procure your infrastructure. It has state-of-the-art server and serverless services for you, and and like I said, it has the biggest market cap out there. So definitely they have a very big global footprint. They have, so these dots, they are different regions, and in each region they have set up different kind of data centers. So whichever region is closest to you, you can set up your workloads in that data center, and you're good to go. By the way, this is what generally a data center looks like. And it gives you a lot of going to the cloud and working and building your data engineering and your applications on cloud infrastructure gives you a lot of advantages. You can go global in minutes, right? Which essentially means that you don't have to spend your time in in procurement of your servers, in security of your servers, in patching your servers, right? You don't have to do that. You just need to deploy your application and you're good to go, right? And it is horizontally scalable. Means, for example, now currently your business application, or for example you have a e-commerce store, right? It has 5 million customers, right? And within like a week, for example, there is a sale coming in or something like this, there is a need for you have an estimate that your user will climb up to 10 million, so it will double. That means you have to double your infrastructure as well. You can do that in minutes in the cloud. If you're not in the cloud, it will definitely take a lot of time and effort, right? You can stop spending capex, right? Capital app expenditure, which is the amount you spend upfront, right? For installing your servers. You can stop spending that, and you just care about the operational expenditure, pay as you go model, right? If you're using one server, you pay for that. If you're using two, you pay for only that. Okay. And you don't have to guess the estimates, right? So for example, previously when we were going through the scalability part of it and seeing the on-prem systems, we have this guess that okay, these 10 servers will be enough for the next 3 years, right? But there is another requirement that comes halfway through 3 years, right? So you have to guess again, right? So there are a lot of advantages around that. I'm going to skip through that. We can come back to them later. What I want to do is go to building a very basic data engineering pipeline on AWS, right? So normally what you will do, you will procure a server, right? Buy a server, something like this, install an operating system on top of that, install some patches on top of that, install your data engineering applications on top of that, and then you will start working on your code or your SQL queries. So there is a lot of prerequisites that you have to do. But with AWS with AWS's serverless offerings, you can pretty much do this instantaneously, right? So let me just move on to AWS's console. I think I have opened it here somewhere. Just a second. Okay. So this is my AWS console, and what I will try to do now, there is a very common task that data engineers have to do is they are getting data in the form of files, right? And they want to query that data in the form of database tables, right? So what they have to do, they have to open the file. They have to check each and every column. They have to check how many number of columns are there, how many data types are there, and they have to build a schema or structure of that file, and then they have to load it into a database table. With AWS, you can do this with some existing services that they have, right? So for example, they have this S3 service, AWS S3 service. You can search it in the search bar here as well. AWS S3, scalable storage in the cloud, right? So all the data lakes that are built on AWS, they use this service S3, which is a simple storage service, right? You store data in the form of buckets. Buckets are essentially, you can say these are directories in the cloud, right? So let's go ahead to and create a bucket. Let's give it a name, data engineering webinar. Let's hope it's unique. There are a lot of options. You can change the region that is closest to you. You can check you can change the access control of the bucket, so specific users can access. You can enable public access, you can enable versioning, different kind, you can enable encryption, different kind of things. But just let's create a bucket for now. So okay, that was pretty quick. I have a bucket now. Let's create another one. We will let's name it logs. I will tell you that what is the purpose of this later, but let's create another bucket for now. Create a bucket. Okay, So it's just like you have bought a server, you have installed an operating system. There is a folder structure inside of that. You have created a folder, and now what you are going to do, you are going to load some data in that folder. Okay, let's upload. Let's add some files. Okay, let's see if I have any latest files. Let's check for CSV files. Okay, I have this file that I have downloaded some time ago. It's some data that I got from AWS's data repository. Let's upload this. Okay, so what this is doing, it is oh, it's a quite a big file, 19 MBs. Maybe we should go with a smaller one. Okay, let's let it upload first. In the meantime, what we'll do, we will introduce you to another service, which is AWS Glue. Glue is a very diverse service. What this service can do, this service is a catalog, right? Catalog means that it takes care of all of your metadata, right? Metadata means your number of columns, type of columns, of whatever there in your database, in your source data, right? And it has other capabilities as well, right? It has crawlers that can crawl through your data and guess or infer your schema or your data types, right? It has ETL job. You can build ETL jobs on that as well, right? So pick up data from one S3 bucket, transform it, and place it into another S3 bucket or some other destination, right? For now, what we are going to do, we are going to create a crawler now, right? Like I said, crawler means that it will crawl through your data, whatever data you have, and it will create a schema on your data, right? So you don't have to do it on your own, right? So what I will do, I'll go ahead, add a crawler. Let's give it a name, data engineering webinar, or whatever you want. You can give it some tags to differentiate it from your other crawlers if you have some. Let's keep it the same for now. Uh, let's click next. I think is it stuck? No, let's refresh one time. I think there might be some network issue. Okay, let's it was fine. Okay, let's building webinar. Okay, let's wait this time because I think there is some network issue. It is causing some delays. In the meantime, let's check the file. Okay, the file has been loaded, and we can see that it's a CSV file, and it's currently in this bucket. Okay. Taking some time. Let's start fresh. Let's go to crawlers again. Add a crawler. Data dash engineering. Let's do it quickly. Next. Taking some time. Can be due to my network or internet issue. In the meantime, we can go back to some of the questions that we might have. Okay, it's progressing. Okay, so we have created a crawler with data engineering name. Crawler source type, we don't have any existing tables. We want to create a new table. Let's click on next. There can be multiple data stores, right? So currently, sorry about that. Currently, we want it to be S3, and connection. There's if there should be no need for connection because it's in the same cloud. But you can set up JDBC connection for some other databases that you might have, like Oracle, MySQL, etc. The specified path is in my account. Let's click on it again. This might need some time to refresh. It should show these buckets that I have created here. So I can select and point it to this data. Okay. Let's close this one. In the meantime, when it's loading, let's go back to some of the questions that we might have in the chat, and I would like to engage my guests, Munib and Moeed, to answer some of them. Right.
So
Roadmap, we
basically,
will discuss
so
that.
basically, Bilal, yeah, there was one question. So basically, someone actually asking about the difference between database and data warehouse and data lake. So I can,
Okay.
I guess that's a valid question and even a good question. So I think I can answer on that. In the meantime, you are actually doing that demo part. So,
Okay.
well, the question what's the difference between database and data warehouse? So basically, we can say if you guys are already familiar with database, so basically databases are there in which we actually create some databases, and inside that database we are actually creating different tables, and the data is always in a tabular format, right? So in the form of rows and column. What you really need to do is you can write your SQL queries on your tables to manipulate the data, right? But the terms that what's the difference between database and data warehouse? Data warehouse is itself also a database, but the we can say the designing technique for data warehouse is a bit different, right? So whenever we are actually designing a data warehouse, is basically the concept, the modeling techniques behind data warehouse is a bit different when we are designing a simple RDBMS. Usually what we really do is OLT, the term we are using is OLTP. OLTP is online transaction processing system. Most of the time they're highly normalized system, like we are actually applying the third normal form on the systems, and basically that is highly normalized. We remove the redundancies and anomalies with these systems, and they're actually meant for handling your operational need. And then this data need to be basically need to be inserted in some other system, that is our data warehouse. So basically the modeling technique in data warehouse is a bit different. Usually we use dimensional modeling when we are creating our data warehouses. So most of the time we are using maybe if you guys have heard about the term star schema and snowflake schema. Basically these are actually the modeling techniques, or dimensional modeling in general is a technique that we are using in data warehouses. So basically because in data warehouses, our core purpose is to do the reporting on the data that we have that is coming from multiple source systems. And then the last term, that is data lakes. Data lake is basically the term we are using where the data that is actually in databases and data warehouses are we can say are structured data, like in the form of rows and columns. But when we talk about that data lakes are actually let's say S3 is our data lake. So basically, the thing is, if we have a data that is already in structured format, and if we have data that is not in structured format, maybe we can say semi-structured or unstructured. So basically, in data warehouses or in databases, that data need to be in specific format. Then the data can be inserted into the tables. But what if we have data, we are not aware of the format of that data first? Then what will we do? So basically, we can put that data simply in our data lake, irrespective of the formats. So two terms that we are actually using when we differentiate a database and data lake, or data warehouse or data lake, is basically schema on read and schema on write term. So basically, schema on write term is basically used for data warehouses or databases. Like if you want to do some analysis on any file or data, so basically you have to insert that data in some table. So inserting data into table, the prerequisite for that process is you should be aware of the format of the data, like the number of columns, their data types, etc. Right? Without knowing this, you are unable to basically manipulate the data. But in when we talk about data lakes, so the term we are using is schema on read, right? Right? Schema on read is a term we are using when we talk about data lakes. Like we can put or dump any data, irrespective of their formats. Like if there were hundreds of columns, like they have 10 columns or 100 of columns, the data is structured or semi-structured or unstructured. We can put simply in our data lakes. But schema on read means whenever we need to manipulate the data, then at that time, like right at the time of writing the file, we don't need any schema information with us, right? But when we have to manipulate the data, then we apply the schema information on that particular data and then manipulate it. So that actually the general difference between these terms. Yes, Bilal.
Yes, thank you so much for the quick answer on this one. Let's move on to some of the use cases. In the meantime, my connectivity will be back. Mohit, I would like to. Can you guys see the screen that we have slides?
No, no, no,
Can you
no, no,
guys
no.
see the
We are
slides?
No.
actually no, we are actually having a screen of your chat right now.
Okay. Can you guys see it now?
Yes.
Yes, like
Okay, great. I'm having some connectivity problem with my account, I think. So in the meantime, we will move on to some of the use cases that we might have on a data engineering from a data engineering point of view, right? So like I said, that this can be a very simple data engineering pipeline that we can build on AWS, right? So we have raw data coming in an S3 bucket, which is just a folder. We can crawl through that data and we can query it using SQL in a service called Athena, right? If you're doing it on your own, you have to buy some servers, you have to install all of these services and do things this way. Similarly, there are a lot of services and there are a lot of interfaces that AWS provides to move data around, right? So for example, AWS has a database migration service, right? So it will migrate your on-prem database to the cloud. It has a snowball service, right? So it is essentially a device. You copy all of your data. It is a very high-speed device. AWS sends it to you. And you can copy all of data on that, and it will be migrated to the cloud. Similarly, Kinesis and managed service or Kafka are also are services for real data coming in, right? You can build catalogs on top of that for your metadata. So in any cloud platform and most of the state of the art data engineering platforms out there, they have decoupled data from metadata, right? So they have metadata in separate stores and they have data in separate stores, right? So S3 is used to hold your data, build data lakes, and in Glue you can build catalogs where what is the meaning of your data, what your data represents, that resides in these kind of catalogs. Then you can analyze using these kind of different services: Athena, EMR for your big data processing, Redshift for your analytical workloads, Elasticsearch for your quick indexing of your text searches on the cloud. Similarly, you can consume using Jupyter notebooks, some API gateways, or you can use Amazon QuickSights dashboarding tool, or you can install your on-prem tools like Looker, Tableau, or these or Power BI, these kind of tools. You can install these by procuring servers in the cloud. And a more complex ETL pipeline on AWS will look something like this, right? Remember that we have seen a similar pipeline in the beginning of this presentation, right? But this pipeline is used has been built using AWS's services, right? So we have different sources. Data is coming in from different sources. We have built a data lake, right, on in S3. So ingestion is happening in data lake. Then you are using some analytics. EMR is for big data workloads, Elastic MapReduce service, and for real-time workloads, you have Kinesis Analytics, and for machine learning workloads, you have SageMaker. So for all kinds of workloads, AWS has these special services to transform and prepare your data, right? And then maybe you are storing it into a warehousing data warehouse, which is Redshift, or maybe if this is text data, you want to search on it, you're storing it in Elasticsearch, something like this. Maybe you're doing some machine learning models you're on top of that, or maybe you are consuming it in the form of dashboards at the end. In all of these services, there is not one single service from the on-prem systems, right? AWS has services in all of these areas for ingestion, data lake, transformation, data warehousing, and presentation layer, right? For all of them, AWS has specific services built on top of that. But that does not mean that you cannot use your on-prem services on AWS. If you want to use on-prem services, if you, for example, you want to use Firebolt or Databricks or Teradata instead of Redshift, right? There is the Amazon marketplace. From there you can download these services and install in a server on this public cloud, right? So instead of Redshift, maybe you can use Teradata here, right? And instead of S3, maybe you set up your own data lake using HDFS. If you want to, you can do that as well, right? So it's dual advantage. If you think that AWS is providing some service that is better, you can use that. And if you think that you want more control over some service, you can install that on your own, right? So this is what a complex data engineering pipeline on AWS might look like, right? Now coming back to a data retention challenge or data retention use case that we face generally in most of the systems. And I would like to request Moeed to explain this use case. Why data engineers need to take care of data retention, and what data retention is generally, and how this data engineering challenge can be solved through AWS very easily. Over to you, Moeed.
All right. Okay. Thank you, Bilal. So basically, I hope you heard the term retention before. So basically, when we talk about data in any enterprise, the term that is actually more important for any like manager who's actually looking after the data warehouse. So basically, data retention is what, let's say, if you have some database or so you have data warehouse, and definitely that has some limited storage. Let's say we can say it's 20 terabyte or 30 terabyte. But the normal operation is basically every day new data from different sources came, and basically you have basically ETL process is running it. So basically you're extracting the data from multiple sources and then transforming it and loading it into your data warehouse. So basically your data warehouse size keep on increasing, right? But what will be the downside for that particular approach? And definitely after a couple of months or weeks or months, maybe after 6 months, your storage will get full, right? You get a message like your storage is 99% consumed. So what will you do? What will be your next step or next move? So definitely, you will have to delete some older data, right? But at the same time, we are saying data is equals to money these days, right? We really don't want to delete the data. So we are actually what we really want is to have the data with us, but at the same time, our data warehouse or database size keep on increasing. So basically, basically this is actually the situation any organization basically is facing, must actually facing this kind of situation. So basically, we have to apply some retention policy company-wide. Let's say, if we talk about my previous organization, their retention policy is 13 months, right? So basically, they have to maintain 13-month data within their data warehouse for reporting. The data older than 13 months should be archived. But at the same time, we are not deleting this data, right? The data older than 1 year or 13 months, we are actually not deleting this data. We are applying the retention policy. Any data that is older than 13 months should be placed somewhere else, right? So keeping that thing in mind, so basically in AWS, like we have a concept of cold storage, not particularly AWS, but in general, we have a term that we are actually using is cold storage, and we can say the hot storage. Hot storage is basically, we can say your data warehouse is. The storage basically you are using to, and you are putting that specific data that are frequently, that you are, or the business user or the stakeholders are frequently using, right? That 1 year data or 13-month data that is actually required for reporting should be in your hot storage or in your database. It can be Teradata, it can be IBM DB2, it can be AWS Redshift. Redshift is basically the data warehouse service for AWS, right? The data that is older than particular retention period after like a 1 year or 13 months need to be removed from your hot storage and should move into your cold storage, right? Cold storage can be S3, or we can say S3 Glacier, right? These are actually the cold storage. So basically, you just dump that data in this cold storage, and in cold storage, you actually put that data which we are not, we can say required frequently. The unfrequently accessed data we are actually putting in our cold storage. So basically, this is actually we can say the challenge or use case basically every organization face. So basically, they have to apply some retention, and at the same time, they don't want to delete that data. So what they really do is basically move that data into some cold storage. So talking about AWS, AWS has a data warehouse that is Redshift, and Redshift is basically a distributed environment that is basically companies or organizations are actually using to do their analytics, right? Then there is an additional service that is Redshift Spectrum. So Redshift Spectrum basically run on top of your Redshift cluster, right? So using Redshift Spectrum, like in the next slide, we have multiple use cases where like why we are using Redshift and why we are using Redshift Spectrum. So basically, these are actually the use cases, right? The first one, extend query to S3 data. Like you have some data in your Redshift, that is the database. That is the data warehouse, the columnar data warehouse that are using to do analytics in any organization. But what if you have to do like some query or some analysis on the data that you already archived from your warehouse? Then Redshift Spectrum comes, right? So basically, you basically dump that data or archive that data in S3. And if you have to do some analysis on S3, like in the form of file, the data that is already available in the form of file, but not in your databases. So if you have to do some analysis on that data, so you can use Redshift Spectrum. That is actually a service actually provided by AWS. So you don't, there is one more use case here. So what if the data older than 1 year, so you have to perform some analysis on that. One way is you actually move that data back into your warehouse or into your database, but that process is time consuming and resource consuming, right? But what we really do is using that Redshift Spectrum technology, and using this technology, what we really do is we don't move any data from anywhere, like from S3 to Redshift. We are not moving there, but we are not doing this. So basically what we are really doing is S3 data in S3 is remain there, and using this technology, we are actually pointing to the particular file, let's say CSV or TSV in any format, the file is there. So basically, we are just creating a table just like we used to do in databases. And then at the end, we just add one more line of code that is actually pointing to that particular file in your S3 or in your data lake. And after that, we can do any analysis just like we are using in, we are doing in any database or in Redshift. So through using this technology, basically we can extend query to S3 data. The data that is in the form of file, we can do analysis or analytics on the data that is in the form of file. So this is one of the use case. And next slide, Lal, can you please move into the next slide? Yeah, the other case is storage optimization. So using this technology, basically what we really do is, sorry. So basically, storage optimization is a second use case. And in this, we are having only that data that is actually frequently used in our Redshift cluster, in our database, in our data warehouse, and the data that is actually we are not using frequently, we are actually move that data in our S3 or S3 Glacier, or right. So basically, doing this, we can optimize our storage. Yeah, next slide, please. Yeah. So talking about the cost, right? So if we talk about the cost for this whole process, right? So we don't need to set up for Redshift Spectrum. If we talk about the Redshift Spectrum technology, we really don't need to pay anything for the provisioning of service or the monthly charges. So this is actually a serverless service, right? So basically what we really do, we can say is serverless analytics. So in that, we do not care about any backend infrastructure like the cluster or anything. So basically, Redshift is already there. That is actually a cluster-based service. And on top of that, we are actually running this service. So we only need to pay that minimal amount, that is $5 per terabyte of table data scan. So you have your data in your S3, and if you want to do some analytics or analysis on that data, that is already in S3. So basically, what you really need to pay is just $5. That is very minimal cost for any organization. So $5 per terabyte of data scan. So if you scan 1 terabyte data, you only need to pay $5 to AWS. So by doing this, like we can say the scanning cost definitely can increase, but that will be very minimal, like we can say $100 or $150 maybe, but that again will be very minimal. But if we talk about the we can say the other point, that is help reduce storage cost, right? So basically for scanning, you have to pay $5 per terabyte, but for otherwise, if that technology doesn't exist, you have to move that data in your hot storage, and hot storage cost is very, we can say very high as compared to this $5, right? So this is actually the use case that is actually in general using by many organizations, or even working in StartPlay, where we are actually using this use case as well. So we actually dump some data that is already not frequently used in our buckets, and then if we have to do some analysis on this data, so basically we are using Redshift Spectrum, right? So that's it.
Okay, I think that was a great explanation. In the meantime, I have gone ahead and tried to run this pipeline. I got my connectivity back. So what we were doing, we were on this slide, and what we were doing, we were trying to load data in S3 bucket, right? And crawl through that data so that we know what kind of data types, what kind of columns are there, and then query that data using AWS's service, which is Amazon Athena, right? So what I did, I created this crawler, right? And what this crawler will do, this crawler will crawl through this S3 bucket that we have created. Let's open this one as well in a different tab. Okay. So this is the bucket, data engineering webinar. Okay, this crawler will crawl all the files present in this bucket, right? And it will give us a table. Let's open this table in a separate tab. You can see this table has been added. If I click on this one, I can see its schema, right? So what glue crawler has done is crawl through this location, check all the files. There was only one file in that location, and infer that schema for me. For a normal data engineer, they have to, or which is doing something on prem, they might have to do it by themselves. But using these AWS services, you can do it in a very automated way, right? Similarly, we can set some settings here from here as well. We can edit this table, we can edit this schema ourselves, maybe add some other columns, maybe correct some data types that we might think are not correctly picked, something like this. So this schema will always be there, right? And if I want to query this table, what I can do, I can go to this service, which is Amazon Athena, and I can select from this table, select star from webinar.ts and run this query. Okay, what Athena will do, Athena will connect to AWS Glue, right? It will pick up metadata from there, right? Metadata, that is the name of the columns and the data types. And then it will go to that S3 bucket, right? And it will go to this S3 bucket, read this data, and provide me with a tabular view of this data, right? So you can see here that these are some incident numbers, some offense code. So this was like Boston crime data, something like this. I got this from AWS's repository. Okay, so you can query directly from S3 here. You don't have to load data, ingest data into, create tables first, ingest your data into those database tables, and then query that. If you are in a hurry, you can use these services. A lot of pipelines include these services because it is very easier to query with these on raw data, right? Because in database world, most of you might be familiar with that, that you have to pick up data from files and insert that into that database table, right? But in Athena, it is not inserting into any table, it is just picking up directly from file and showing you in a tabular form, so you can make more sense of it, right? So this is what a very basic, very you can say mellow type of pipeline that is very common to build in AWS's infrastructure. Uh, these are very common services that we use. One of them is S3, which is for your data lake. Glue is for cataloging your data, so storing your metadata, and it can also be used as an ETL tool to load data from S3 to another S3 bucket or some other destination. And Athena is used to query files in the form of tables, and show it you in the form of tables from the S3. And you guys, and thank you, Mohit, for explaining that use case to us of retention, right? How we can extend our query capabilities to our data sets, how we can optimize storage using AWS's data engineering infrastructure, and how we can reduce our cost, because the data warehousing and setting up this infrastructure is very costly, right? Like someone said in the beginning. So how can we reduce that cost? So that was, I think, very good explanation on this. We have two more challenges, availability and security, that we saw earlier. And AWS, they have SLAs on availability, security, and these kind of things, right? So for example, for their S3 service, they have 11 nines, 99.999, so on. Durability, durability, that means that if you place a file in S3, uh, there is one in how many is it, billion or 10 billion, 1 in 10 billion chance that this data will be corrupted or will not be there, which is very unlikely, right? Similarly, for availability, 99.99%, it is very rare that AWS's or these public clouds, they go down or they face an outage. It is very, very rare. Even if they face like in 1 in 10,000 or 100,000 times, your data will still be there once the public cloud is up, right? And they have SLAs, right? So if they are not providing 99% availability of your data, they will pay you back, right? Because they are breaching their service level agreement, right? So this is pretty good thing for building your data engineering pipelines, because you are getting those guarantees of availability and durability. Similarly for security as well, because nowadays there's been huge debate of on data privacy and data security. So AWS has a shared security model of your data and for your infrastructure, right? So AWS takes care of all the hardware, all the physical security of their hardware where your data is stored, and they make sure that they have compatible licenses. They make sure that they are following those licensing, updating those licensing, patching properly their systems. But at the same time, they want you to be vigilant as well. So for example, if you're storing your data in the cloud and you have some port open and your data got stolen, then it's not AWS's responsibility to close that port, right? You have to close those ports and make those IPs private so nobody can access your data, right? These kind of things. Similarly, you have to take care some of the patching that you do if you want to install your own operating system, these kind of things. And maybe you want to encrypt your PII, which is personal identifiable information, anything related your CNIC, ID cards, phone numbers. If you're storing this kind of data on AWS, you should encrypt that or tokenize that in AWS for proper security. But for as far as the hardware and storage and database level security goes and networking level security goes, they do take care of that at their level. Before moving to the questions part, I will quickly go through the roadmap, because a lot of you have asked the roadmap question. I found this really great GitHub link that shows a data engineer roadmap. It's for 2021, but I think it's pretty accurate, and it's very thorough, right? And I will definitely want some comments from my guests on this uh, on this uh, uh, on this roadmap as well. I wasn't able to, because this is a very big picture, I wasn't able to fit these into the slides, but you can see it from here. I can share this one on chat, so you guys can access this as well. Uh, so for becoming a data engineer, if you want to start, if you whatever point you are in your data engineering journey, there are some fundamentals that you have to go through, right? um, it is saying, how does a computer work? This, I think most of you people already know that version control is one of the very important things, right? Version control is, most of the people use Git, but it's used to control this control flow of your code, right? So for example, if we are three developers working on the same code, we don't want to uh, we don't want to have any merge conflicts on that same file, right? So we should be able to use some version control systems, Git, or with that GitHub or Bitbucket or something like this. Similarly, it is saying that you have to some basic knowledge of terminal uses. If you guys don't know what a terminal is, it's just like your CMD, but it's in Linux, right? You should have some command on that. It will be very helpful. uh, uh, and you should have some knowledge of Linux. It says that you have data structures and algorithms knowledge as well, as a general recommendation. But in most of the data engineering tasks, you won't uh, you won't use that data structure and algorithms knowledge, at least in my opinion and or in my experience. But this knowledge will definitely help you in the interviews, because people they tend to ask these basic concepts. So maybe you should brush up on those skills. Maybe look for some basic searching and sorting algorithms like bubble sort, merge sort, insertion, quick, something like this. some searching algorithms like binary search, so something like this. You should know these algorithms, which are very basic, and you should know their time complexity in big O terms. So then this will be very helpful if you want to start out. Then next come a programming language. Like Mohit said before, this is very important as well. Python has become the de facto standard nowadays. So if you know Python, you're pretty much good to go, because Python works with uh, almost everything, right? But if you are in application development, so for example, if you are developing some application to solve a data engineering problem, you're not using current application, you are developing another application, then maybe you have to go through Java, but that is not necessary for most of the data engineering job. Python, SQL, and some Linux will get you through most of this. Next part is the database fundamentals. All of these points are very, very important. You should know SQL, normalization, and ACID. What these things mean. They will help not just in the job. They will help you in the interviews as well, because a lot of questions revolve around these concepts. Then there is some testing. So whatever workflow you are building, you should be able to unit test it if test it its integration with other parts of your pipeline, and functionally test it as well at the end. You should know these concepts as well. These are most of these are discussed here as well. So for example, we have discussed horizontal and vertical scaling. We have discussed OLTP versus OLAP. There's CAP theorem, which is mostly related to NoSQL databases, and dimensional modeling, which is a very important concept when you are building data warehouses and building workflows that loads data into your data warehouses. Similarly, databases, you should have interaction with some of the relational world of databases, even if it is only one of them. MySQL is very common, and if very common, and Postgres is also very common open source database. It is very commonly used for big data workloads as well. Then there is MariaDB, Amazon Aurora. Amazon Aurora is Amazon's own database service. This is a distributed database service which is across region distributed. So this is getting popular as well. Some non-relation or NoSQL databases. If with the passage of time, you will definitely interact with these as well. But for starting out, you don't have to. Most important ones are MongoDB, Cassandra, and maybe Redis. These are considered the most important ones. MongoDB and Cassandra are pretty widely used for big data workloads. If you are using cloud-based database, then maybe you're using DynamoDB or Google Bigtable. These are very popular as well. Uh, for data warehouses, there are a lot of different options. But if you have worked on a relational database like MySQL or Postgres, you might be you might be might become familiar quickly with these data warehouses as well, because most of these are SQL based, like Snowflake, Redshift, right? The only difference is these are cloud based, right? Similarly, you must have interaction with object storage as well, which is which is used for building data lakes, like we just saw one example of Amazon S3. uh, Similarly, some different fundamentals which come around clusters for distributed computation. Apache Hadoop is very common one, and in cloud they have managed services around the same framework. So Amazon has EMR, Google has Dataproc, Azure has I think it's not data lake, it's something else. I think there is a typo here. For data processing, there are a lot of tools. uh, you can see that it is a very clear roadmap, and it is very diverse, and it might be overwhelming for some of you people, right? But most of us don't interact with all of these tools on daily basis, right? So for example, currently we work with Spark. Currently we work with HDFS. I think we work with Redis and MongoDB, right? So these are part of a bigger ecosystem. So sometimes you're working only with Spark, sometimes you're only working with MongoDB, sometimes you are only working with just writing SQL queries as a data engineer, and sometimes you are resolving some integration issue on your system level or Linux or operating system level, right? You guys can start you guys can go through this one, maybe start anywhere, right? So you can start from just simple shell scripting or scheduling. You can start from basic Python, you can start from basic SQL, and then move upwards from there, right? But in all its entirety, I think there are three basic skills that data engineers should have. One is the skill of Linux. You should be able to interact with Linux, use the terminal using the bash language. The second one is SQL. You should know what SQL is, how to interact with tables and databases using SQL. And the third one is Python. So if you so you should be familiar with Python. So if you have to write some custom jobs, get data from some APIs or build APIs, for example, you should be very you should be needing Python or some programming language. So I think these three skills are kind of must-haves. Rest of the things vary from tool to tool, but if you possess these three skills: SQL from the database world, Python from programming world, and Linux or usage of terminal or shell scripting from the operating system or the administration world, you will be good to go. I think we are pretty much complete. We have completed pretty much completed our slides. If you guys have any questions, or if you think there is anything that I've missed during this, please go ahead. The floor is yours. We can extend this to 10 or 15 minutes more for your question if you have any. In the meantime, let me go through the chat. Latest first. Okay, someone is raising a hand. Okay, I think it's Tayyab. Please go ahead, Tayyab.
Thank you so much, sir. Sir, I have a question. Sir, जिस तरह अभी आपने ये Amazon वेब सर्विसेज का बताया और इसके थ्रू डेटा इंजीनियरिंग का कॉन्सेप्ट दिया है, तो देयर आर अदर टूल्स एज वेल, जैसे हमारे पास ये SQL सर्वर मैनेजमेंट में SSIS है, तो वो भी तो डेटा इंजीनियरिंग के लिए यूज होता है टूल, तो ये वेरी करता है, मतलब यूज केस टू यूज केस?
That's a very good question, Tayyab. So let's take a step back. एक स्टेप पीछे जाते हैं और देखते हैं कि SQL सर्वर या SSIS को यूज करने के लिए आपको क्या करना पड़ता है. ठीक है, आप पहले एक सर्वर लेंगे या एक कंप्यूटर लेंगे, उसके ऊपर ऑपरेटिंग सिस्टम इंस्टॉल करेंगे, उसके ऊपर फिर आप SSIS इंस्टॉल करेंगे, उसके ऊपर आप SQL सर्वर इंस्टॉल करेंगे, और फिर उसके बाद आप अपने एक्चुअल काम की तरफ आएंगे, जो बेसिकली क्या है कि आपने डेटा एक जगह से लेके आना था और उसको क्वेरी करके देखा. ठीक है, नाउ दिस इज अ वेरी टीडियस प्रोसेस, राइट? बट इन क्लाउड, लाइक यू हैव सीन, कि मुझे ये सारे स्टेप जो इंफ्रास्ट्रक्चर सेटअप करने वाले हैं ये बिल्कुल भी नहीं करने पड़े हैंड्स ऑन में. मुझे डेटा अपलोड करना था, मैंने अपलोड किया. मैंने उस डेटा को क्वेरी करना था, मैंने विद इन 5 मिनट्स उसको क्वेरी भी कर लिया. ठीक, मुझे इंस्टॉलेशन, इंफ्रास्ट्रक्चर सेटअप, ये सारी चीज़ों से नहीं गुजरना पड़ा. स्टिल इफ यू आर यूजिंग दिस ऑन प्रेम, अगर आप अपने डेटा सेंटर में या अपने ऑफिस में ये सिस्टम यूज कर रहे हैं, इट इज़ अ वेरी गुड सिस्टम. ठीक है, जो SSIS और बहुत सी कंपनीज यूज करती भी हैं, SSIS और SQL सर्वर एक साथ, या जो इसका पूरा स्वीट है, यू कैन स्टिल यूज दैट ऑन क्लाउड. ठीक है, उसके अंदर फिर भी आपको ईज ऑफ एक्सेस क्या मिलेगी कि आप जो सर्वर सेटअप है आपका, वो आपका सिंगल क्लिक पे हो जाएगा. आप अमेजोन की सर्विस पे जाएंगे, EC2 पे, इलास्टिक कंप्यूट क्लाउड, उसके ऊपर जाएंगे, एक सर्वर प्रोक्योर करेंगे, आपके पास विद इन मिनट्स वो सर्वर प्रोक्योर हो जाएगा, ऑपरेटिंग सिस्टम के साथ आएगा वो. उसके बाद आप बेशक उसके ऊपर इंस्टॉलेशंस वगैरह आप अपनी कर लें. ठीक है, और यही आपका जो अभी सिस्टम है, यही आप क्लाउड के ऊपर ले जाएं, ठीक है।
राइट सर। सर एक और
तो
क्वेश्चन था मेरा।
जी बिल्कुल।
Sir, can we call a person as a data scientist if he has skills both in data engineering domain and business intelligence domain, or he also need to have the skills in of skills set of a machine learning engineer? Because I think the data science is an umbrella. You are the expert, you can better explain it, but in my perception it is a big umbrella under which these domains lie.
That's a very good question, and it varies, Tayyib, from company to company, organization to organization, right? So for example, if you're working for a startup, right, startups are in their early phase, right? They don't have big money, they don't have big teams, right? So you might find someone who is performing all of these tasks. वो डेटा इंजीनियरिंग भी कर रहा है, डेटा लेके भी आ रहा है, रिपोर्ट्स भी बना रहा है, उसके ऊपर बीआई इंजीनियरिंग वाला काम भी कर रहा है, एंड ऑन टॉप ऑफ दैट वो उसके ऊपर प्रेडिक्टिव एनालिटिक्स भी लगा रहा है, ठीक है, यानी डेटा साइंटिस्ट वाला काम भी कर रहा है, और अपनी मैनेजमेंट को बता रहा है कि अच्छा हम फ्यूचर में हमारी ग्रोथ इतनी हो सकती है, ठीक है, या फ्यूचर में इतने लोग हमारे पास ज्वाइन कर सकते हैं, हमारी प्रोडक्ट को यूज कर सकते हैं, एक्सेट्रा एक्सेट्रा, ठीक।
Right.
बट इन बिगर कंपनीज, बिगर एंटरप्राइजेज, जैसे फॉर एग्जांपल टेलकोज हैं, जैज, टेलीनॉर एक्सेट्रा, या बड़ी कंपनीज हैं, आईबीएम, टेराडाटा, they have specific teams because they have money, they have manpower, they have specific teams. So they might have a team corely focusing on data engineering, ठीक है, जिसमें सिर्फ डेटा इंजीनियर्स ही होंगे जो सिर्फ डेटा लेके आने के लिए जिम्मेदार होंगे, रिस्पॉन्सिबल होंगे, एंड देन दे माइट हैव ए टीम कोर फोकस विच हैज कोर फोकस ऑन डेटा साइंस, जो सिर्फ मॉडल्स बिल्ड कर रही होगी, जो सिर्फ मशीन लर्निंग मॉडल्स को यूज कर रही होगी। दे डोंट नो कि डेटा कहाँ से आया, वो सिर्फ डेटा इंजीनियरिंग टीम को रिक्वेस्ट रेज कर देंगे कि हमें ये डेटा चाहिए एनालिसिस के लिए या प्रेडिक्टिव मॉडलिंग के लिए, वो डेटा इंजीनियर टीम उनको वहाँ पे डेटा ला के दे देगी, ठीक।
Right, sir.
सो
Sir,
आई
last
थिंक दिस इज
question.
द मेन डिफरेंस। आप पूछ लें, क्वेश्चन पूछ लें।
सॉरी सर, जस्ट लास्ट क्वेश्चन वो ये था कि जब आप डेटा वेयर हाउसिंग का कॉन्सेप्ट बता रहे थे स्लाइड से, तो यू डिस्कस के जो हमारा OLTP होता है, उसमें सर मोहित ने भी ये बात की थी कि OLTP में वी हैव हाईली नॉर्मलाइज्ड डेटा and it takes a lot of time for the analytics to draw useful insights from that data. तो दैट इज़ फाइन, क्योंकि अगर वो एक बहुत बड़ी साइट है ई कॉमर्स की और दे हैव 10 मिलियंस ऑफ यूजर्स, तो अगर सर लाइक अगर कोई पॉइंट ऑफ सेल की जिस तरह आपने एग्जांपल दी थी, तो उसमें हम OLTP को ही एज अ ओलैप ले सकते हैं। लाइक अगर मैं ये कहूँ कि डेटा नीड ऑफ डेटा वेयर हाउसिंग वेरीज फ्रॉम केस टू केस, तो ये बात ठीक होगी ना फिर?
Yes, definitely. That is actually true. So for example, let's go back to उसी कैश एंड कैरी वाली एग्जांपल के ऊपर जाते हैं, ठीक है। सो योर कैश एंड कैरी इज यूजिंग एन OLTP सिस्टम, जिसके ऊपर आप स्कैन करते हो, उसके अंदर रो आ जाती है, ठीक है। और अब आपकी कैश एंड कैरी का टाइम है, सुबह 8 बजे आप वो शॉप खोलते हो, और फॉर एग्जाम्पल रात को 11 बजे तक आपका टाइम है, ठीक। तो दैट मीन्स के योर ट्रांजेक्शनल सिस्टम इज गेटिंग यूज, पीपल आर बाइंग प्रोडक्ट्स फ्रॉम 8 in the morning till 11 in the night, ठीक है। उस टाइम के लिए तो वो ट्रांजैक्शन वर्कलोड्स के लिए यूज होता है, लेकिन नाइट में आफ्टर 11 12 मिडनाइट के बाद वो सिस्टम आइडल है, क्योंकि आपकी दुकान बंद है, ठीक, कोई बंदा कुछ खरीद नहीं रहा। तो उस टाइम के अंदर, यानी नाइट के अंदर, आप उसके ऊपर अपने एनालिटिकल वर्कलोड्स भी रन कर सकते हो, यू कैन डू दैट, ठीक है, अगर आप नहीं उस पर स्पेंड करना चाह रहे। बट स्टिल जो आपके ट्रांजैक्शनल सिस्टम है, दे आर नॉट डिजाइंड फॉर एनालिटिकल वर्कलोड्स, दे विल टेक सम टाइम, एक्स्ट्रा टाइम। ओके, फॉर एग्जांपल अगर एक क्वेरी एनालिटिकल सिस्टम पे अगर 1 मिनट में चल जाती है, तो शायद वो ट्रांजैक्शनल सिस्टम में बहुत ज़्यादा टाइम ले चलने में, ठीक है। यू कैन डू दैट, but it's not recommended to do that, ठीक है जी। मूविंग
राइट
ऑन,
सर, थैंक यू सो मच।
उसके बाद किसका क्वेश्चन है? आई थिंक समवन इज रेजिंग द हैंड, लेट मी सी द पार्टिसिपेंट्स। ओके, तैयब ने पूछ लिया। फरुख, you are raising your hand, please open your mic and ask if you have any question. Farukh Raza. Okay, Farooq, we are not able to hear you. Perhaps if you can
Hello.
share it
Can
in
everyone
chat.
hear me?
Okay. Yes, we can hear you.
Okay. Assalamu alaikum, everyone. So my question is related to that very basic question, the data warehouse and data lake. के ये जो data अभी हम शायद one of the guests discussed that the data lake is that database in which we import raw data, and then when we have to manipulate the data, then we use some other thing, maybe data warehouse or any other thing. So मेरा सवाल ये है कि जब हमने raw data import कर लिया और उसके अंदर possibly बहुत सारी data types वो बिल्कुल raw as a raw form में import हुई, ये भी possible है कि कोई integer जो है वो varchar के अंदर import हो गया मिसाल के तौर पर। तो अब हमको जब उसको मैनिपुलेट करना है तो मैनिपुलेट या सम निकालना है तो वो varchar का सम नहीं हो सकता। तो हम फिर क्या करेंगे? हम उसी डेटा लेक के अंदर उसकी कोई नई स्कीमा डिजाइन करके और उसके अंदर फॉर्मेटेड डेटा लेके आएंगे या उसको कहीं और लेके जाएंगे?
That's a very good question. Anyone from my guests, Muneeb and Moeed, if you want to take a lead on this one.
Yeah, I think I can take the lead on this one. So just to reiterate the question, to understand, it's to that we have brought in raw data, and now we are building an actual schema on top of it. So in my experience, and as far as I have seen, usually when we bring in raw data, it's just to confirm that the data has been handed over by the source system. Okay.
Yes.
And afterwards, there are a couple of things that are required to make it more of a represented and actually a usable data source. So the question that you have, we never do that activity that we bring in data and then we rely that, okay, whatever has been brought in and whichever way it has been brought in, we are going to use it. No, the entire process of pipeline is actually to transform that data into a very friendly way. Now, the friendly way could be for the application. You have like Tableau at the end of the day, where the data is going to be presented in dashboards. Or it could be for an end user, where the end user is basically using it through a reporting cycle. So the entire process of pipeline is to go through that data, not only just transform the data types, but also to make it more in an aggregated form that it's easier to query as well. When we talk about OLAP system, there is a very big difference between these and the OLTP systems. The OLTP systems will tell you the story and point in time, but OLAP systems are usually presented in a form of aggregated data sets. So all this process is done in stepwise approach in the data pipeline. So you won't see an occasion that the data has been brought in and we have built everything on top of that raw data. You will always do some kind of transformations on that data, and that will be your pipeline itself.
तो ये जो ट्रांसफॉर्मेशन होगी ये हम उसी डेटा लेक के अंदर करेंगे या ये किसी और लेवल के ऊपर करेंगे? कोई डेटा वेयर हाउस में ले जाएंगे या डेटा लेक के अंदर ही हम किसी और टेबल के अंदर हम उसको ट्रांसफॉर्म करके यूज करेंगे?
So it depends. There are both possibilities. You can do this like you have a raw data table. Like for example, just like you said, we have data and now we built a raw data table on top of it. Now I want to transform. The next step I want to do is reevaluate all the data types and bring it the data into another, like you can say clean data format in another table. You can do it in the same data lake. Or if you see that if I do this activity in this data lake, it will get so consumed by the transformation that it might not be able to serve other users. So what we can do is we can offload it and do it in another application. We can do it in Spark, transform the entire data, do the same activity, and just pull it back in to the data warehouse again. So it depends from use case to use case.
There are the same data lake, in the same.
It depends.
In the Spark. Okay.
Yeah, and bring it in. Maybe you don't want to bring it. You want to separate the raw data.
We can still say it data lake. We can get raw data in it, and then we can manipulate. We manipulate it and stored in the same data lake. So can we say it data lake where the raw data is present and the manipulated data is present at the same?
जी बिल्कुल सेम में हो सकता है. देखें फरूख, Let me go back to this example. जो हम let me see अगर मेरे पास वो open है तो-
Farooq, just to add, it's going to be the difference will be in your logic. It won't be that you're talking about. Logically, you have separated. Now you have both clean and uh, uh, raw data at the same time. If you want to separate them and you want to say, okay, no, I only want to keep raw data in one lake, I will create a very clean lake for another one. That's up to your logic and business. Of course, there will be some additional steps. You will be paying extra for an additional storage capacity as well. You will have to separate these resources from, you will have to decouple them so they are not highly integrated, that one fails and the other completely fails as well. So these will be requirements. You are working in the same ecosystem. It will make your life easier. So there are pros and cons for both approaches.
अच्छा, मेरा एक थोड़ा सा वो था जो प्रीवियस क्वेश्चन किया था इसने जलील साहब ने, तैयब जलील ने, उन्होंने क्वेश्चन किया था कि भाई OLTP को ही हम यूज कर लेंगे। तो मेरी एक वो है, समझ लें कि ऑब्जर्वेशन इस हवाले से है कि जैसे इन्होंने रिस्पॉन्ड किया था बिलाल साहब ने कि आप यूज तो कर सकते हैं, लेकिन मेरा अपना वो ये है अंडरस्टैंडिंग कि दिस इज नेवर recommended to use the main transactional database as a analytical database, क्योंकि वो उसमें ट्रांजेक्शन हो रही होती है, वो बहुत सेंसिटिव डेटा होता है, उसके अंदर आप जब एनालिटिक्स या मैनिपुलेट उसको कर रहे होते हैं तो चांसेस होते हैं कि वो मॉडिफाई हो जाए या डिलीट हो जाए या ट्रंकेट हो जाए, कुछ भी हो सकता है। तो इट इज ऑलवेज अ गुड प्रैक्टिस to transfer that data to an OLAP प्लेटफॉर्म। प्लीज मुझे गाइड करिएगा अगर मैं इसमें, ये मेरी अंडरस्टैंडिंग दुरुस्त है।
नहीं, डेफिनेटली आपकी अंडरस्टैंडिंग बिल्कुल दुरुस्त है, इसलिए मैंने भी उसके एंड पे ये कह दिया था कि इट इज नॉट रेकमेंडेड, लेकिन आप करना चाहें तो कर लें, फिर क्या ही कह सकते हैं।
Just to add on this one, just to add, the example is, it's better to understand some things with example. आप रिवर का पानी जो उनसे पीने के लिए भी यूज कर सकते हैं और आप क्रॉप्स के लिए भी यूज कर सकते हैं, ठीक है। इट डिपेंड्स यूज केस, बट इट्स बेटर टू यूज द रिवर वाटर फॉर द क्रॉप्स, बिकॉज आपको पता है कि वो अभी क्लीन नहीं है, लेकिन वही वाटर हो सकता है काफी सारी जगहों पे एग्जैक्ट सेम रिवर वाटर विल गो थ्रू डिफरेंट प्रोसेसेस ऑफ क्लीनिंग एंड देन विल बी सर्व टू द हाउस होल्ड। ओके, ये एक बड़ी इसकी कॉमन एग्जांपल है। और आप जाके, लेकिन आपको कोई रोकेगा नहीं कि यू कैन गो देयर एंड जस्ट पंप द पानी वाटर आउट योरसेल्फ। So it's very use case specific. It's meant to be used for the online transaction systems that are doing the transaction in real time and maybe in a staggered way. But the OLAP systems are usually point in time, so they usually cut off in a certain time, and they give you a better approach to get the history of the usage rather than a very specific format. And usually another example is you will see the history in an OLAP system for a very longer time as compared to OLTP system, which usually tell the story for a very specific certain time. Afterward, they start dumping the data because they're not meant to have that consistency of data for a very long. You can get data for 3 to 5 years in OLAP system, but OLTP may only tell you the story for 3 months. What are you going to do when you go back in that?
Thank you.
I think let's try to conclude. We are already past our scheduled time. I would just like to, because there was this question of this data sets or something where we can find these data sets. I will just share a couple of resources which you can go through. I think one is Kaggle. You can go to Kaggle for these kind of data sets. Other one is AWS. History of AWS open data. You can find different data sets, right? Big data sets are also available on these, both of these, right? So if you are doing some experimentation or you want to learn something using big data sets, you can go to these websites and download data sets from there. Kaggle has also some competitions that you can join to explore data and to derive insights from this data. Okay, someone is asking where we get the recorded video. Zainab, are we recording this session? I think we are recording this session. I think it will be available on the same event link. and it will also be available on YouTube, I think. So you can go to YouTube on Dice's, I think Dice has a channel. So you can go on that and check for upcoming videos or something. Okay, so I think this is it. I hope that you guys have enjoyed this session. I hope that you guys have learned something from this session. And I hope that if you're starting out, whatever point in your data engineering journey you are, I wish the very best to you. You can, I think someone is asking another question. Yes, you can definitely connect with me on LinkedIn, Bilal Maqsood. You can connect me with LinkedIn. By the way, other speakers are open for this as well. You can you can connect with them as well on LinkedIn. No, anytime. Uh,
All right.
okay.
Now, if you're done with the session, I'd like to formally conclude the webinar. To all the attendees, we hope you enjoyed the session and learned something out of it too. Thank you so much for participating. The attendees can email us for the recording or any queries regarding our trainings at info@diceanalytics.pk for those of you who were asking for the recording of the webinar. And thank you so much to the respected guest speakers, Mr. Bilal, Mr. Mueed, and Mr. Munib for joining. We had a great time on this webinar with you. Thank you.
Thank you so much, guys. Take care. Bye.
Thank you all. Bye.
Thank you, sir. Thank you so much.
सर एक क्वेश्चन का आंसर कर दीजिएगा.
Yes, definitely. आप पूछ सकते हैं.
सर मैं पूछना चाह रहा हूँ कि जब हमारे पास ओपन सोर्स डेटा वेयरहाउस डेटा लेक के सॉल्यूशन हैं लाइक केकबाइट पाइपलाइन एंड डिफरेंट सॉल्यूशन हैं जिनको डीबीटी ट्रांसफॉर्मेशन यूज करके हम ट्रांसफॉर्म कर लेते हैं लोकली होस्ट करके हम अगर उसको डायरेक्ट AWS की क्विक साइट में हम जाके कनेक्ट कर लेते हैं कनेक्शन क्रिएट कर लेते हैं और एक ही हमारा कनेक्शन होता है जिसको हम मल्टीपल विजुअलाइजेशन डैशबोर्ड्स में हम यूज करते हैं व्हाई वी मूव टुवर्ड क्लाउड स्टोरेज सिस्टम दैट इज मच कॉस्टली देन लोकल डिप्लॉयमेंट.
ओके, आई थिंक वैसे इसके ऊपर थोड़ा सा हमने पहले भी डिस्कशन की थी और इसका मेन जो आंसर है ना वो ये है कि आप डेफिनेटली आप कर सकते हैं. ठीक है, डेफिनेटली इस तरह कर सकते हैं. आप अपना इसको ऑन प्रेम कहते हैं. ठीक है, आप 10 सर्वर्स लें उसके ऊपर अपनी
रिसेंटली आई हैव वर्कड ऑन.
ठीक है, उसके ऊपर इंस्टॉल करें अपना सब कुछ. ठीक है, उसके ऊपर सब कुछ चला लें. बहुत सी ऑर्गेनाइजेशन इस तरह चलाती भी हैं, खासतौर पे वो ऑर्गेनाइजेशन विच हैव सम डेटा प्राइवेसी या जिनके पास सेंसिटिव डेटा और वो क्लाउड पे नहीं रखना चाहिए. दैट इज फाइन. ठीक है, लेकिन उसकी एडेड कॉस्ट क्या है कि आपको सर्वर्स पे एक तो अपना टाइम इन्वेस्ट करना पड़ता है चूज करने में, उनके ऊपर आपको पैसा इन्वेस्ट करना पड़ता है, उनकी सिक्योरिटी फिजिकल सिक्योरिटी अपने डेटा सेंटर की, पैचेस वगैरह ओएस वगैरह सब कुछ आपको खुद करना पड़ता है. ठीक है, इस हैसल से बचने के लिए आप क्लाउड के सोल्यूशन यूज कर सकते हैं. ठीक है, जिसके अंदर आप सिर्फ अपने डेटा इंजीनियरिंग की लॉजिक को देखते हैं, आप इस चीज की अंडरलाइंग इंफ्रास्ट्रक्चर की केयर नहीं करते. ठीक, जैसे अभी किसी ने पूछा था कि मैं SSIS पे भी कर सकता हूँ SQL सर्वर. जी कर सकते हैं, आप डेफिनेटली कर सकते हैं, लेकिन उसमें क्या है, पहले आप OS सर्वर खरीदेंगे, OS इंस्टॉल करेंगे, उसके ऊपर SQL सर्वर इंस्टॉल करेंगे, फिर डेटा लोड कर सकेंगे. ठीक है, ये 4 स्टेप आपको इंफ्रास्ट्रक्चर सेटअप करने पड़ेंगे पहले. लेकिन क्लाउड में जैसे अभी हमने हैंड्स ऑन में देखा कि मैंने डेटा लोड किया और फौरन क्वेरी कर लिया. ठीक है, तो मैं उस हैसल से बच
बिल्कुल
गया.
वो तो
ठीक है,
बड़ी हैसल से आप बचे हैं. लेकिन
दूसरी चीज के
सॉरी मैं कुछ ऐड अप करना चाहूंगा.
जी जी करें, आप ऐड अप कर लें.
बेसिकली लाइक मैं जहाँ पे काम कर रहा हूँ हम S3 बकेट्स को यूज कर रहे हैं. हम S3 बकेट्स के साथ सेल्सफोर्स और डिफरेंट अदर टूल्स यूज कर रहे हैं. तो हम उन सारे हालांकि क्लाउड सोर्सेज हम क्लाउड स्टोरेज यूज कर रहे हैं, लेकिन बाकी जो साइड अलॉन्ग विद साइड लाइक डिफरेंट चेकआउट्स हैं, डिफरेंट पेमेंट गेटवेज हैं, मुख्तलिफ जगह से इंफॉर्मेशन हमने लेके आनी है. तो हमें इस तरह का क्लाउड स्टोरेज बहुत कॉस्टली पड़ जाता है. तो इसके लिए ये सूटेबल वे नहीं है कि हम एक पाइपलाइन क्रिएट करके हम उसे एक पोस्टग्रेस का या कोई और जो है लोकली डिप्लॉयड एक डेटाबेस क्रिएट कर लेते हैं और उसको यूज करते हुए करते हैं. तो ये कितना जो कॉस्ट इफेक्टिव है?
ये दिस इज अ ट्रेड ऑफ. ठीक है, कि इफ यू आर गेटिंग वन थिंग तो शायद आपको दूसरी चीज ना मिले. ठीक है, तो ये आपके बिजनेस का डिसीजन है कि वो क्या यूज करना चाहते हैं, ठीक है। जैसे फॉर एग्जांपल आप S3 में डेटा लेके आ रहे हैं, ठीक है। आज आपके पास फॉर एग्जांपल 10 TB डेटा आता है, ठीक है। एक महीने बाद आपके पास 50 TB आने लग गया है। तो क्लाउड आपको ये फैसिलिटी देता है कि आप हॉरिजॉन्टली स्केल कर सकते हैं ऑटोमेटिकली, ठीक है। लेकिन अगर यही आपने पोस्टग्रेस में लोकली रखा होता और एकदम डेटा बढ़ जाता तो क्या होता, फिर आपको कुछ ना कुछ डिलीट करना पड़ता ना, कुछ वैल्यूएबल चीज आपको खत्म करनी पड़ती, ठीक है। तो इट्स अ ट्रेड ऑफ, आप कर सकते हैं, ठीक है। लेकिन एट द एंड ये आपके बिजनेस का और आपकी मैनेजमेंट का डिसीजन है कि वो किस तरह से करना चाहते हैं। इधर वो क्लाउड को यूज करना चाहते हैं, ऑन प्रेम यूज करना चाहते हैं, या हाइब्रिड यूज करना चाहते हैं। मोस्टली मैं देख रहा हूँ कि लोग अब हाइब्रिड अप्रोच की तरफ जा रहे हैं, जैसे आप कह रहे हैं, ठीक है, ताकि उनके पास कंट्रोल भी रहे और वो क्लाउड के बेनिफिट्स वगैरह भी ले सकें।
इसमें मैं सिर्फ स्मॉल एक चीज ऐड करना चाहूंगा कि द बेस्ट थिंग, जब आप क्लाउड के साथ डील करते हैं ना, तो आप अनएक्सपेक्टेड के लिए प्रिपेयर्ड होते हैं, ठीक है। यहाँ पे क्लाउड आपको बेस्ट परफॉर्मेंस देता है कि अगर इफ यू आर नॉट श्योर कि कितना डेटा होगा, ठीक है, क्या चीजें हैं, आपके पास बहुत सारे एब्स्ट्रैक्ट वैल्यूज हैं, ठीक है, जो कि आप नहीं एक कंक्रीट वैल्यू रखते, तो उस टाइम क्लाउड आपको बेस्ट परफॉर्मेंस देगा। वो अगर ज्यादा हो जाता है तब आपको वो परफॉर्मेंस प्रोवाइड करेगा उसकी, अगर कम हो जाता है वो स्केल डाउन करके आपको कॉस्ट सेविंग की तरफ ले जाएगा। तो ये दोनों ट्रेड ऑफ आपको एक साथ ही वो देगा कि आपको नहीं करने की कुछ जरूरत है कि एक बार आपने सेटअप कर दिया प्रॉपर्ली, यू हैव कॉन्फ़िगर्ड इट इन अ मैनर के स्केल अप एंड स्केल डाउन हो रहा है, तो जब आपका इन्फ्लक्स बढ़ जाएगा, लेट्स से रात को 12 बजे बढ़ गया, आप सो रहे हैं, ठीक है, लेकिन वो अपने आप को एक्सपेंड करेगा, ठीक है, और 1 घंटे के लिए बढ़ा था, उसके बाद वो स्केल डाउन उसको करते, तो आपको कॉस्ट इस 1 घंटे की बढ़ी है, लेकिन आपका कोई भी कस्टमर है वो उसको कैंसिल आउट नहीं हुआ, इसके रिजेक्ट नहीं किया गया, उसको सर्व किया गया है, और आपकी एक तरह से उसमें आपको एक एक्चुअल वैल्यू मिली है कि आपका कस्टमर सेटिस्फाइड हो वहां से।
सर ये चीज़ जैसे हाइब्रिड अप्रोच हम यूज़ कर रहे हैं कि हमारा कस्टमर सफ़र नहीं करता, एकदम हमारे पास अनोमली आ गई है, बहुत ज़्यादा डाटा आने लग गया है, तो वो कस्टमर तो सफ़र नहीं करेगा। हमारे पास जो है डाटा वो हम उसको अकॉर्डिंगली मैनेज तो कर रहे हैं। तो इस सॉल्यूशन में क्या हमारे लिए ये ज़्यादा इफेक्टिव हो सकता है कि हम जो डाटा वेयर हाउस हमने बनाई हुई है, उस कंप्लीट जो डाटा लेक जिसके थ्रू हम डाटा प्रोसेस कर रहे हैं, उसको कंप्लीट क्लाउड पे ले जाएं?
Once again, it's completely use case to use case dependent. Okay, there will be applications that are gonna best perform if you have it in house. They will give you better performance because there is no internet connectivity in between them, and there will be applications that your user interface is on the cloud itself. Okay, and it's better to have the connectivity over there in the cloud as well. So it's very use case to use case dependent. You cannot just you will have to pick and choose between what you want. Sometimes you want to save cost, so you're gonna have your customers wait a little bit, and sometimes you want performance on certain aspect, maybe on certain pages itself, or certain aspect of application. You want paid users to be served automatically as soon as possible, but you want the free users to wait a little bit in a queue. So these kind of things depend on the use case to use case. A proper answer that you can take everything into cloud without looking in the background, it's not really a proper answer or complete answer.
Thank you so much, sir.
Okay, guys, let's conclude. Thank you so much. Take care. Allah Hafiz.
Yeah.